Dear students, welcome back. So in the previous lecture, I told you how to draw the graph of a linear equation in two variables. Now we did a few sums on that also. So today we'll start with few more sums, and then I'll tell you about the graph of a line which is parallel to x-axis or y-axis. Now, first of all, today's first question. If the point three comma 4 lies on the graph of the equation of the equation 3y is equal to ax plus 7, then find the value of a. Find the value of a. Now you see, as 3 comma 4 lies on the graph of this equation, that means the value of x is 3 and the value of y is 4. We know there can be infinite points on this line. That means there can be infinite values of x and corresponding values of y, but one of them is 3 comma 4. So put x is equal to 3 and y is equal to 4. Put x is equal to 3 and y is equal to 4. When we put x is equal to 3 and y is equal to 4, then you will see 3 into 4 is equal to a into 3 plus 7. Now 3 into 4 is 12. 12 is equal to a into 3 plus 7. 12 minus 7 is equal to a into 3. 12 minus 7 is 5 is equal to a into 3. Then a will be equal to 5 upon 3, and that is your answer. The value of a we have found 5 upon 3. Okay. I'll give you one more question. And the question is, if the point minus 3 comma 8 lies on the graph of the equation of the equation 3ax minus 7by is equal to 11. If the point minus 3 comma 8 lies on the graph of the equation 3ax minus 7by is equal to 11, and if a is equal to 2b, then find a and b. If a is equal to 2b, then find a and b. Now see, as I told you here, as minus 3 comma 8 lies on the graph of this equation, that means x is equal to minus 3 and y is equal to 8 is one of the values, one of the infinite values that x and corresponding y can have. So put x is equal to -3, y is equal to 8. Put x is equal to -3, y is equal to 8. So 3a into -3 minus 7b into 8 is equal to 11. That is minus 9a minus 56b is equal to 11. Okay. Now see, a is equal to 2b. So in place of a, you write down 2b here. Minus 9 into 2b minus 56b is equal to 11. Now it is minus 18b. Minus 18 and minus 56 will be minus 74. Minus 18 and minus 56 is minus 74. Minus 74b is equal to 11. So b will be equal to minus 11 upon 74. And now if b is minus 11 by 74, a is 2b. So a is equal to, when you multiply it by 2, so it is minus 11 upon 37. So these are the values of a and b. A is equal to minus 11 upon 37 and b is equal to minus 11 upon 74. Clear? That is your answer. Next question. Draw the graph of two x minus 8 is equal to 0. Now you can see this is a linear equation, but it is not in two variables, but it is in one variable. One variable is missing. Clear? 2x minus 8 is equal to, and now we have to draw the graph. Now when there are two variables x and y, we draw the table and then we get, for various values of x we get values of y, and then we plot them and draw the graph. But here the situation is only the x is there, y is missing. Now what we do, 2x minus 8 is equal to 0. So 2x is equal to 8. If you shift 8 to that side, then x will be equal to 8 upon 2, that is 4. Now you can see we are getting x is equal to 4, means according to this equation x will be 4 whatever be the value of y. It does not depend on value of y, whatever is the value of y, but the value of x remains the same, that is 4. So now if you draw the graph, now you see when y is 0, then x is equal to 4, because I told you x is always 4 irrespective of value of y. So when y is 0, x is 4. When y is 1, then also x is 4. When y is 2, then also x is 4. When y is 3, then also x is 4. Okay? That means if you draw the graph, you can see the graph is parallel to y-axis. Clear? So the equation of a line parallel to y-axis will be of the form x is equal to a, where a is the distance of the line from origin. Okay, so the equation of a line parallel to y-axis, as this line is parallel to y-axis, is of the form, will be of the form x is equal to a, because it is x is equal to 4, x is equal to a, where a is the distance of the line from the origin. Now you can see it is of the form x is equal to 4, and the distance of the line from the origin, this is the origin, and the distance of the line from the origin is 1, 2, 3, 4, 4. Clear? Okay. Next question. Draw the graph of 3y plus 15 is equal to 0. Once again you can see here also, definitely it is a linear equation, as the highest power of y is 1, but it is not in two variables but in only one variable, that is y only, x is not there. Now 3y is equal to minus 15, as we shifted 15 to that side, so y will be equal to minus 5. Y is minus 5. Now see, that means the value of y will always be minus 5, whatever be the value of x. Irrespective of the value of x, the value of y always remains minus 5. So when you draw the graph, one, two, three, 4, 5, 6, 7. These are the values of x, and these are the values of y. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Now you see, when x is 0, y is minus 5. I told you, irrespective of the value of x, value of y will always remain minus 5. When x is 1, y is minus 5. When x is 2, y is minus 5. When x is 3, y is minus 5. When x is 4, y is minus 5. Now if you join these points, then you will see The graph is a straight line which is parallel to x-axis. So you can write the equation of a line parallel to x-axis will be of the form y is equal to a. The equation of a line parallel to x-axis will be of the form y is equal to a, where a is the distance of the line from the origin. Of the line from the origin. The equation of the line parallel to x-axis will be of the form y is equal to a, where a is the distance of the line from the origin. You can see it is of the form y is equal to -5. So a is -5 here, and the distance, you see the line is here from origin, the distance is -5. If the line is on the negative side, then you will take the distance in negative, and if the line is on the positive side, then you will take in positive. Okay. Next question. Solve the equation 2x plus 1 is equal to x minus 3 and represent the solution on first part, the number line, second part, the Cartesian plane. Cartesian plane means on the graph. Okay. So first of all, you have to solve this given linear equation, and then you have to represent the solution on the number line and on the Cartesian plane. First of all, they have given 2x plus 1 is equal to x minus 3. That means 2x minus x. is equal to x is equal to minus 3 minus 1. 2x minus x will be x only. Minus 3 minus 1 will be minus 4. So you have got that x is equal to minus 4. Now first of all, if you draw it on the number line, zero, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, and now your value is x is equal to minus 4, so simply put a dot here. You have to put a dot on minus 4. So this is your answer on the number line. You have shown there we are getting x is equal to minus 4. Simply on the number line I have shown x is equal to minus 4. Clear? Now we will show it on the number line. Now you see x is minus 4. That means x is always minus 4 irrespective of value of y. It does not depend on the value of y. That means when y is 0, then x is minus 4. When y is 1, then also x is minus 4. Then y is 2, then also x is minus 4. When y is 3, the x is minus 4. The value of x remains the same. If you join them, you will get this straight line. So you can see the line, the graph is a straight line which is parallel to y-axis and at a distance of minus 4 from the origin. That I have already told you that whenever a line is in the form of x is equal to a, it will be parallel to y-axis and the distance of the line from the origin will be equal to a. Clear? Now, the next question. Give the geometric representation of y is equal to 3 as an equation in first part in one variable, second part in two variables. Okay, first part in one variable, second part in two variables. Now, first part, it is given that y is equal to 3. Okay, now how to represent it geometrically? You draw a line parallel to y-axis. Now, is 0, 1, 2, 3, 4, -1, -2, -3, -4, and now it is y is equal to 3, so simply put a dot on 3. So this is the graphical or the geometrical representation of y is equal to 3. Now the second part, the equation remains the same, y is equal to 3, but now they are saying you have to show it in two variables. So you write down 0 into x, as x is not there. So 0 into x plus y, or 1 into y, is equal to 3. 0 into x plus 1 into y is equal to 3. Now you see, as x has to be multiplied by 0, so whatever be the value of x, y will always remain 3. So this is the origin. Now you see, when x is 0, y is 3. When x is 1, y is 3. When x is 2, y is 3, and so on. So if you join them, you will get a line, and you can see this line is parallel to x-axis, and its distance from the origin is 3. As I told you that whenever a line is parallel to x-axis, it is of the form y is equal to a, where a is the distance of the line from the origin. So this is the geometrical representation of the line of the equation in two variable, and this is in one variable, because here we have taken only y as the variable, but here both x and y. Now I hope it is clear to you that whenever a line is parallel to x-axis, it is of the form y is equal to a, and whenever the line is parallel to y is equal to parallel to y-axis, then it is of the form x is equal to a, where a is the distance of the line in either case from the origin, and a has to be taken with sign. Means that if the line is on the positive side of origin, then you will take the distance as positive, and when the line is on the negative side of origin, then you will take in negative. Clear? So now we have done a lot about drawing the graph of a linear equation, both in two variables and one variable. Now in the next class we'll start we'll do few word problems based on linear equations, and we'll solve the equations both graphically as well as algebraically. Okay, so in the next class we'll start the word problems.